Thank you. Let's see, make this go away. So we're going to get our projects open, but I wanted to talk about this first. So we have these vector positions. If you think about it, in the textbook they show us X, Y positions. We actually have 3D positions, so we have X, Y, Z, but it works just the same. So they're focusing on just the X and Y. So if you think about it, at the top of our slingshot, or where that Y position is, we have our launch position. That's one vector coordinate, right, an XY position that we have in our game. Then wherever that mouse is clicked, right, somewhere in our launch position area is going to be another vector position. So we need to make some movement happen from this position here of our launch position towards that mouse click. Now we have a third kind of positional issue, and that's going to be the maximum. So we're going to limit that mouse to a certain area around our projectile, and that certain area is going to be defined by our max magnitude variable. So if they were to try to move the mouse, or if the mouse was outside of that maximum, we would use that maximum as the mouse position. So let's look real quick at this Khan Academy video. Let's see how it, maybe. Because I think that this one is pretty good, and like I said, everybody's in different spots. It's pretty short.
For adding and subtracting two-dimensional vectors. So let's say that I have vector A, and let's say that its x component is, I don't know, 3, and its y component is 1. And let's say we also have a vector B, and let's say that its x component is 2, and let's say its y component is 3. Now let's first think about what would A plus B equal. So what resulting vector would this be? A plus B is equal to what? And I encourage you to pause the video and think about what this would be. Well, the convention is if we're taking the sum of two vectors, we can just add up their x components to get our new x component, and add up their y components to get the new y component. So the x component of vector A plus vector B is going to be 3 plus 2. That's going to be the x component, which we know is 5. And the y component is going to be -1 plus 3. -1 plus 3. And so the resulting vector is going to have an x component of 5 and a y component of -1 plus 3 is equal to 2. All right, that was pretty straightforward. Now instead of adding them, let's think about what would happen if we subtract them. So let's think about what vector A minus vector B would be. And I suspect that you might be able to guess, or at least think about what would happen if you subtract vector B instead of adding vector B. Well, as you might have guessed, instead of adding the corresponding components, we subtract it. So our x component is going to be the x component of A minus the x component of B. That's vector A minus vector B. So our x component is going to be 3 minus 2. 3 minus 2. And our y component is going to be the y component of A, -1, minus the y component of B. So -3. And so the resulting vector is going to be the vector 3 minus 2, the x component is going to be 1, and then the y component -1 minus 3 is -4. Now what I just showed you, this is the convention for adding and subtracting two-dimensional vectors like vectors A and B. Let's see.
So there's lots of information out there if you want to watch the rest of that, but I think everybody's should have a pretty good understanding at that point, because we're just going to do some simple vector subtraction here. And in our code, they want us to notice that we're going to just be Let me say it right. So A minus B gives us the vector distance between A and B, which is also the distance and direction that one must move to get from point B to point A. So a mnemonic to remember is that A minus B looks at A. So as we're moving something across, that's just some helpful thoughts for us because we're geometrically moving things across the screen. So let's put that code in, but I want you to be thinking about what's happening as we put it in, because there's some math concepts that we might need to clarify on. All right, so Unity, you have your project open? Find your project. Let's try to run it. You know how sometimes Unity breaks things? Well, we haven't been playing with it. It's amazing. It gets so lonely. Okay, I've got a green here. If I click, I should see my projectile. So that's where we left off. Everybody got it okay? Do we need to post anything? All right, great. So where our code is that we're going to start messing with, we only have one script in this one right now, and it's our slingshot script. That makes things a lot easier than that apple tree game where we had so many different scripts. Not quite as object-oriented, but a little bit easier to find. So in our slingshot script, we're going to be working with our update method. Our update method right now only has that terrible if statement in it that says if we're not in inning mode to return. And just get out of the script. So let's add some stuff under there. First of all, in our text, they say we want to get the current mouse position. And whenever we're working with the mouse, we're working with a 2D position. We're going to create a vector3 variable to hold that position called mouse POS 2D. It appears that we've lost even more connectivity between Unity and Visual Studio, at least I have. It's worse. I'm not getting any sort of feedback about it at all. So we're going to have to try our hardest to not mess anything up. We're establishing our vector3 variable, and we're using the input class to ask for the mouse position. Then once we get the mouse position, we've got it saved in our new vector3 variable. So let's use that mouse position 2D and set our Z position so that we have a 3D position for this thing. Just like before, we want to set that position based on our camera. So we're going to use camera.main .transform .position .z. So let's think about all of those different steps. We want the z coordinate based on the position properties. If we were looking at the inspector for this variable, we want those position properties, our XYZ positions, from that transform area. Remember, the transform has position, scale, and rotation. We only want the position information from that. We only want the z coordinate from that. The object we want to get that from is our main camera. What position is it? Let's get its z coordinate, and we're just going to set this position to use the same z coordinate so that it's the same depth in space as our camera. Now, once we've got that z position, we'll create another vector3 variable, our mouse position in 3D. And we're going to set that, again, based on our main camera. we're going to call the Unity class that converts that position into a world point. So this is about as complicated as we get. I mean, no matter how far deep you get into making games, when you start having to be concerned about these different coordinates and stuff, is the complicated stuff. So you'll have some sample code. The deeper we can get our understanding of it, the better off we'll be when we have to do more complicated things with other games. Now, the next thing we want to look at is the delta position. I have a couple of other terms up here on the board, but can anybody tell us what a delta position would be?
Changing position.
A what?
Changing position.
Changing position. Anything else?
The third position.
The third position? Let's check. Let's Google it and see if we can find something that explains it pretty good. Better put a little bit more there. I'm getting a bunch of dental stuff. It looks like it could be even a financial thing. So it talks about, there's a lot of Charles Schwab stuff. Are you seeing a lot of those? Those don't seem helpful. How about delta position in Unity? So there's some information on the Unity forum, it looks like. Let's look at this Unity answers, delta position, see if it's helpful. Just looks like that's just a lot of questions. Here's an HTML one, maybe that'll help us.
Got it.
Got it? What'd you find?
Delta position is the distance between touch location and every frame.
So what's that mean? That sounds like a good explanation.
If you say, what is the delta position Unity, then it seems to have a little more accurate stuff.
It can find all that information for you. And here's a good explanation, like looking at the time. It says it can be as simple as, I'm looking at the clock right now, it's 9:30 p.m. I look at the clock now, it's 10 p.m. So the time elapsed is 30 minutes. So we can have lots of situations where those start and end times don't even matter, but that 30 minutes is what we're concerned about, like how long to cook a cake, things like that. So like you guys said from the very beginning, a changing position. It's that change in position from one position to the next position. Where are we going?
So it's just tracking each refresh.
Tracking it as we're refreshing. Very, very good. So good way to figure it out. You know, sometimes when we're looking at code and just getting it in there, it can be easy for us to just go ahead and not really think about what something means. But it'll be better in the long run if we stop and say, well, what exactly are we putting in here? So we're looking at the difference, basically, between that launch position and that mouse position that we clicked on. So we're going to create a new variable to hold that. Again, it's going to be, bless you, a vector 3. We're going to call this one mouse delta. So it's going to be our mouse position 3D minus our launch position. So again, it's going to be that vector subtraction. This is exactly where we're going to be using that vector subtraction to get that delta position, the distance. Now again, we want to limit that to the radius of our slingshot. This our sphere collider. So we're going to grab that information into a variable max magnitude. So our script is associated with our slingshot. So this is our slingshot, right? This slingshot. Get the sphere collider component of this slingshot when we add our components to these objects. One of the things that we added to our slingshot was a sphere collider component. Get that component and give me its radius value. So then we can use that to set that limit. So we're going to check if our mouse delta magnitude, how big it is greater than our max. We're going to limit it. So we're going to use the normalize method. And overwrite our mouse delta. Make sure that it is within our area. I don't think they mention what that normalize method does. Let's check and see. Oh, they do. So the mouse delta.normalize method sets the length of mouse delta to 1, but keeps it pointing in the same direction. And then we multiply that mouse delta by our max magnitude to get a valid position. Now we would need a little bit more code here and then we'll be ready to try it. That's one we probably need to look up a little bit more. We'll come back to it. Now we're ready because we are going to trust that math to move the projectile to this new position. So to do that, we're going to create a vector 3 object called projectile, or PROG-POS. We're going to calculate it by adding our mouse delta value that we've been working on calculating to our launch position. So we'll do a vector addition there. Get that new position. We're going to take our projectile then and update its transform position values, X, Y, and Z, to our PROJ POS variable that we just created. So that line is going to move our projectile to the new position. Now, one last little thing. We're going to check our mouse. And if our button up value is 0, then the mouse has been released. We're going to set our aiming mode to false. They're not aiming anymore. We're going to set our is kinematic to false. Just clean some things up here. Oops, my projectile there, I should have projectile rigid body. And then on the next line, projectile rigid body. We're going to set our velocity. So it's ready. And then we're going to make it kind of disappear. Okay, I think we should be ready to test. Sometimes when you look at chunks of code like this, it makes you be discouraged, but don't, because you're going to have these samples and you're just going to be able to try things. That's the great thing about Unity, is you can just try some different things and see how it impacts stuff so that you can develop a better understanding of what's going on there. Does mine work? I need to save all and go to Unity and try to run it. It was like it was slowly learning what a vector 3 was, but I don't know if it was doing it well. Okay, so now if I hold my mouse down, I should be able to move my projectile around, and when I let go of it, it should shoot. And then I can do shoot straight down and really important things like that. Try it. Yes, sir?
Oh, you can shoot them at each other. Were we supposed to add a rigid body to the projectile?
I think we did. Let me find it. Yeah. So you should have a rigid body. Can you see these settings in the Zoom?
Sort of. Not full screen. 5, 0. Okay, got it.
Got it. Now see if that. And then remember too, you guys said, oh, let's go ahead and tag our main camera as main camera. So if you were getting any errors on finding that main camera position, it's that tagging. See if you need to add that rigid body component to it. So that one would be a variable. Then let's see where that variable is. I think that's one that we just added right at the end last time. Check. There it is. Check your variables up at the top. Let's see if you're. You might need to check one other thing too. Yeah, it should be in there twice. The set dynamically stuff. Can you go ahead and share your screen with us? Everybody can see it. Or you can't do that with your laptop, can you? You what? Okay. Heather's projectile is not showing up, so we're going to take a look and see if we can figure out why. Hello, share your screen. Either get at it. Oh, yay, yep, you did. Okay, show everybody what happens. Oh, wait, so go to your console screen. Yep, right below your mouse. See that tab? Yep, click it. And then which one is it talking about? Slingshot. Line 31, let's check your script. Set your tag for your camera. So tell them how to do that, you guys.
Your main camera.
Yeah.
In the hierarchy.
Then click on it. Then in the inspector under tag, click it. Then check main camera. There you go.
Now run and let's see if that changes anything. It should at least help with those errors. Oh, there we go. Now it's still got an error. So let's stop and look at line 34. That looks right, doesn't it? So let's look at your prefab projectile. That's the one you had set in the inspector. So click on your slingshot.
We have 2 slingshot scripts for some reason.
Ah. Now that should help. Oh, now you set that projectile prefab to be your projectile. Good. Now see if you're running without errors. That one will be set in the game, so you're okay. Yay. I guess it's, yay. Awesome. Looks great. Oh my goodness. Okay. Get him off the screen. Okay, that looks good. Save. Save now. Okay, so let's make a follow camera. That's what they're calling it. What other names have you heard for something like that? For a camera that follows a game object? Third person camera. What else? First person. What else?
Second person.
Didn't people call it like a POV camera, different things like that? Have you heard those kind of terms? So yeah, that's what we're going to do is we're going to set up our camera to follow that projectile so we can see what's going on with it. All right, so for this one, we're going to be creating a new script. We want our main camera to follow the projectile when it's launched, but we want it to be something where the camera sits and doesn't really move while we're aiming. And then after the projectile is launched, we want the camera to kind of follow it with a little bit of easing off on it so that it feels kind of smooth. We don't want it to be all bumpy with that thing. As the camera moves up in the air, we want to keep the camera's size growing so that we can see the ground, you know, so that we get that distance. And then when the projectile stops, we want the camera stopping also. So we're going to create a new script. And this one is going to be called Follow Cam. Now for our Follow Cam, first thing that's important for us, let me make sure here, is that we need to change our method names because we're not going to use the start method. We're going to use the awake method. And we don't want to use the update. We want to use fixed update. Just like last time, we want to make sure that we don't leave those empty start and update methods in our script because we could accidentally override things to not do default things in Unity because Unity is like, oh, well, you have an overload for that method, so I'll do what you say, and you didn't say to do anything, so I won't do anything. All right, so now with our follow cam, the first thing we want to do is create a variable here that's going to be a static variable. Now, a couple of things. Remember, a static variable is a singleton, meaning we only have one of them, which is good because we only have one camera, right? So we don't want to have some sort of variable that would let us have, you know, multiple instances because it's different than those types of objects. So we only want one instance of our point of interest. Now we're going to use those compiler directive statements with the square braces and set our header first. The header is going to say these variables are set dynamically. And the variables that we're going to have, it's just this one, a public float called cam z. So this is going to be, whoops, there it goes crazy. I thought it was going to. This is going to be the desired z position of our camera. So in our awake script, we want to set our cam z variable. This script is going to go on our camera so we can refer to it as our this object. We want to get its transform position Z. And then we'll have that saved off. So in our fixed update then, we're going to do an if check first and check to see if our point of interest is empty. And if so, just like in that last script, we're going to do some bad code and just return out of here. Get out of this method. No point of interest. Otherwise, let's get it. Where is this point of interest? We shall see. We'll set up a new variable called destination, and we'll set it to our point of interest location. So our point of interest is going to be like our projectile, right? Because this is the thing we're wanting our camera to follow. So when we're talking about our point of interest, it's going to be, is there like a moving projectile? This is what we want to be tracking. So if there is one, let's grab it. Where is its position right now for this frame? And let's change its Z position to be the camera's Z position. And then let's update camera position to this new destination. Uh-huh. But that's just what they made their variable. And it's a good short variable name, because if we said something like, where is the projectile, our projectile variable name is already a little bit long. So okay, we need to do a little bit more to get all of this working, but I'm going to save this one. And let's go back to our slingshot script. Mine is still open in Visual Studio, so I can just click on that tab. And we want to put this in our update method. It's going to go down, find the spot at the end of our update method where we put in the if statement just a few minutes ago about getting this mouse button up position. So we're looking for that if statement there. Mine is on line 53, but I have some comments and some spaces that you might not have. But inside that if statement, we're going to add a little bit more at the end. So right before we set our projectile to null, we want to add one line of code. We want to say our follow cam dot point of interest equals our projectile. And then wipe out that. So we could put a comment, set point of interest for our camera. Now, if we save everything, we should be able to try it. guess we should add that script to our camera, huh? I did not add the follow cam script, so I'm going to put it on my camera. See if that has an impact. Didn't matter for me.
It moved my ground up though.
Yes.
But that's it?
Yeah. No, it'll follow.
It's following?
Yeah, but it moved the ground like half. It's completely following. So it rolled off the edge.
Mine follows, but it never stops. Probably because it never hits anything. Falls
Just
off the
keeps
edge.
going.
Yeah, that's what it does.
Do you have an error?
It does not exist in current context. Yes, it does.
You all get those? Yeah,
My follow
Mine doesn't work.
Well, you might have a typo.
Hmm?
You might have a typo.
I do. There's finally something showed up. Sometimes it looks like I'm doing nothing, but I'm just waiting.
yeah, you did a capital transfer.
Ah, finally. Where was it?
Yeah.
23.
Yeah.
What is it?
It's in follow cam.
Oh, potion. There it is. So sometimes you just have to wait. It took a long time to come up with that error. I was like, I don't know why it isn't working. Did you get him fixed, Anthony? You are awesome.
Yeah,
Ah, that's better. That's better. There it goes, falling off the edge of the earth. That's what you guys were seeing. And I was like, why is mine not working? Thanks for helping me. I can't help anybody else if mine doesn't work. It just bothers me. You know how that is. Why is the ground moving? We're going to fix it. Yeah, we're going to fix it. So let's fix some issues here. First of all, issue A says if you zoom out the scene pane view enough, you can see the projectile actually flies past the end of the ground. Yes, it does. So to fix that, let's update our transform position settings of our ground. So click on your ground, and in Inspector, they want us to change our position to 100, -10, 0, rotation 0, 0, 0, and scale 400, 1, 4. Now I want to try that and see what they're how they're saying that's what that changes. It's changed a lot. Yeah, it just makes it so big. You can't. You just can't ever fall off. The bowling alley that never ends. Huh? It works. It works. Okay, our next issue says if you fire at the ground, the projectile neither bounces nor stops after it has hit the ground. If you pause right after firing, and select the projectile in the hierarchy to highlight it, and then unpause, you'll see that it rolls when it hits the ground and never stops rolling. So let's see if we can fix issue B. So let's go to our projectile. And what we're going to do is add rigid body and physics materials to our projectile. So I'm going to make sure I'm not running here. And in my project pane, I'm going to select my projectile prefab. Now, in our rigid body component, set the setting for collision detection to continuous from discrete. And they say if you want to know a little bit more about that, you can select the help icon in the rigid body component. So the little question, there it is, little question mark there will bring up your Unity documentation and find out a little bit more about it.
So you can do that with any of them.
With any of them, yeah. So that's really helpful. So if we look at our collision detection, discrete collision detection is used for normal collisions. This is the default value. Continuous let's see, rigid bodies set to continuous dynamic will use continuous collision detection when testing for collision against this rigid body. Other rigid bodies will use discrete. So we'll see how that impacts. But yes, that help is very, very helpful.
For the fast-moving objects, can't go through something without being detected.
So they can't slide through that net. Catch that bullet. Okay, also in the projectile rigid body, open the disclosure triangle next to constraints. I would say expand constraints, but that's the disclosure triangle. Check freeze position Z. And then freeze rotation X, Y, and Z. Freeze position Z keeps the projectile from moving toward or away from the camera, keeping it the same Z depth. And then freeze rotation keeps it from rolling around. Let's save that. So it might not be as fun when I save everything.
They'll do a little bit of rolling, but
Just not much.
But yeah, if you would hit the block, that's going to be there, then it would work right. It would seem like it.
Yeah. Aim at the ground. It just stuck.
If you do it like an angle or
A little bit further.
But then you get stuck with that ball you get shot.
Yep, now I'm stuck. Have to stop. Silly things just stopped us. So we like these rigid bodies, right? Because they keep everything from rolling, but it still doesn't really feel quite right. It's just not exactly the kind of thing that we're used to for physics. It doesn't really feel real. So we want to make sure that everything is a little bit more realistic. So let's add a physics material. Now make sure that I'm on my projectile prefab again, and I want to add a component. Oh wait, no I don't, I'm sorry. Let's try it a little bit differently here. From your Unity menu bar, choose Assets, Create, Physics Material. You see it? Be like our magic cape. Name our physics material P mat. Let me deselected it. So uppercase P M A T underscore projectile. Now, on your physics material, look at your inspector, and we want to set our bounciness to 1. So now we can control it. Let's drag our physics material onto the projectile prefab. So we're gonna have to, let's grab your projectile. Yeah, we gotta, so we have to actually drag it into the sphere collider section. There it goes. Uh-huh. The physics material. So yeah, it's in the material. Thanks. Now let's try it. Should be just a little bit different, not a lot.
Ah, there we go. Now it bounces.
A little better.
Yeah, we can make it bounce a little bit more if we can match the friction.
Yeah, and you could mess with all of those gravity settings if you wanted on your rigid body to try some different things. Okay, the third problem that we have, if you notice, let me run it, is that when we launch our projectile, the camera sort of jumps. It's kind of they say it's kind of jarring. It's sort of distracting because it's not a smooth transition.
It's not directly focusing on the ball.
Yeah, because we've got that distance, so that easing, so that we can see the ground and kind of keep track of where we are in a perspective view, so we don't just lose track. Stop it. This thing wants me to take a survey. It keeps making it where I can't see stuff. All these little pop-ups. It's like even my online book is full of pop-ups. All right, so what do we want to fix? We want to change our point of interest, our follow cam script. So I'm looking at my follow cam script here. And in our fixed update, right after we set our vector 3 variable, we're going to do a lerp. A lerp. So we're going to interpolate from the current camera position toward the destination. So a lerp, the fancy name is linear interpolation, but it's like an easing. So it's like we're going to give Unity this point and this point basically, and say I want you to lerp from this point to this point, and Unity will decide, oh, okay, I'm going to do it in this timing. So it'll be a little bit more, I don't know, animated almost would be the right term, I guess, because you're getting that interpolation where it's deciding how to move things for you. So it just is a little bit smoother movement. So we're going to use the lerp method. And we want to go from the camera's current position to the destination position. And we do want some easing to be applied.
Those are really weird words.
Yep. But you guys know what it means because you've seen it happen all the time. So it's basically this method interpolates between 2 points, returning a weighted average of the two. If the easing is 0, lerp just returns the first point. If easing is 1, lerp returns the second point, kind of the destination. If easing is any value in between, lerp returns a point between the two. Let's run it and see. I want to save this.
It's giving me the name easy doesn't make sense.
Yeah, mine's not understanding.
Is it mad at us?
Is it capitalized on anything?
Is there a using statement we're missing?
No. Does mine not like it either? Yeah, it's got an error.
Mine says expression denotes a type where a variable value or method proof was expected.
Well, let's try. I'm wondering if they're, yep. Let's add a variable that's easy. And how is that gonna, that'll help. So let's do that. So in our follow cam, we have this header that says set dynamically. We're gonna add a new one, a new header for our variables that are set in inspector. And the first one that we need is easing. And we're going to start out with that 0.05F. Another one. A vector 2, which remember just has an X and Y position. We're going to set this as min XY. And we're going to use the vector2.0 property to set that vector2 variable to 0, 0 positioning. Yeah, mine's bad too about that one.
It doesn't like 0.
Doesn't like 0. Does yours not like it either? Are you using your laptop?
Yeah, if you just type vector2 dot, nothing pops up.
Yeah.
What if it's supposed to be in parentheses?
It works in the circular bracket.
Uh-huh.
That is a 0. I'm not sure if that's one called.
Like in, like a parameter? Like that?
Vector2. We got rid of
Nope, got rid of my 2. It takes it. We'll try it. Now we need to add a little bit more code to acknowledge these limits. So we're already using that easing in our lerping, but let's add 2 lines down in our fixed update, 2 more lines. Sorry, kind of.
But what was the? Thank you. Got it.
Got it?
What's the difference between vector 2 and vector 3?
You're only specifying an X, you need to specify a Y, or you'll get angry. There you go. No.
It's referring to the different positions. X, Y. For vector 3, I think it's X, Y, Z.
Mm-hmm.
And then,
Mm-hmm. Okay, so let's limit X and Y to those 2 values, those minimums. We'll take a break here. We better just take a break because Braden had to go. He's got to go. Let's come back at about 9:20.
For your new vector, component, you'll want the X
So the 1, 0 does not overlay both. 0, 0 is setting it.
Does that seem to be working? Okay. Good.
And mine's broke, I can't figure out why.
What's the matter?
I'm not sure, like it has to be something with Unity. It doesn't like the schematic stuff, but it doesn't tell me anything wrong with my code. So what happens is, if it doesn't complain until you hit play, and then you try to like come in here and like do that, and then it freaks out.
Oh, we gotta. The type Unity and stuff like one argument.
Yeah, you have to set the XY code, which is like 2. And as far as what the hell you
So when did it start getting around that? As soon as we did like that.
The physics material.
Yeah, I've been trying to look for it, but I don't.
what is in the point?
Like, I can remove some shit, but I don't think that's the case. Yeah, unless there's just something wrong with my code, it's not actually throwing an error, it's just not getting the expected output. But the only place I can think of where we can do schematic stuff. This one's all slingshot, right?
What it does is it undo there's 2 variations. It changes the so there's
Is this supposed to be false?
No, it's supposed. Oh, just comment out that first one because we replaced it with that second one.
But the only place that we do.
So instead of doing the projectile.get component, we changed it to doing that projectile rigid body dot is kinematic.
Okay, it's still angry. Oh, I don't know. I just don't know what it is next. Like, what's
oh, it's already
is this from Git as well, or is this?
I can try to. I'll try to push it up there when we get done. Remind me, because otherwise I won't.
Because I can't type fast enough even with the auto thing.
You can't.
No.
Do you have your book?
I don't have. I can't do the notes fast enough. Yeah, I have my book.
Well, I can leave it on the spot if you want to get it, but I know it's so hard when we're jumping around so much. So yeah, if you want to just keep trying to go through your book and then see if you can get close to a spot where we are. Because it's so boring if you're not with us. Boring, boring, boring.
Well, I mean, I can type fast enough for the code. I just can't type fast enough for the. Well, I mean, I'm kind of keeping up. It helps whenever you stop to talk.
Yeah. And
But I can't keep up with the comments if I start doing that.
that's all right. We'll start building our castle here pretty soon, so you can just stay with us then, because we're about done with the code for our projectiles and stuff. So we'll build the castle. That'll be where I go. You guys are like, well, just do that. Just do that.
So is there a way you can? I don't want to say speed, because, well, if you just affect the speed of the projectile, then it'll probably do it no matter where you do it on the slingshot. Like, here's the radius of the point where you can go. If you have your mouse all the way over here, then it stays right here, right? But if you have your mouse here, I don't want it to shoot. And like, here's the part where it shoots away from, but if you have the mouse here, I don't want it to shoot about the same speed as this one. But I was wondering if you could somehow alter the speed to go slightly faster or slightly slower.
You could do it like in a lot of ways, but you could do your like on mouse down in your update method and just keep adding to your speed every time that update method runs, that they still are holding that mouse button down. Like if you, or you could check your direction, you know, if you wanted to set your speed based on what direction it was heading. So you could do that however you wanted to control it, so that you could change it. I think that we will in this one. I'm thinking that, I could be wrong, but I'm thinking that it sets the speed up as they hold the mouse button down.
And I have a question about the class. Are we going to, I don't know if this is in the book either, I haven't checked. Are we going to make a person, a playable person, like a playable object that you move around?
Like a player
I mean,
object.
it's
Not so much, but it's
more like
super
a
easy.
person.
Yeah, it's super easy. So just try messing with it, adding in your like different components, first-person shooter and your second, third-person shooter and stuff like that. And when you add it in, they have like default models and stuff that pop up for it. And you can just add in that type of game object and start moving around and see what it does. So just fiddle with it, because they're really easy to use. They really are. But ours does, we don't get into it very much because it's more the concepts of the different pieces, but you would be able to apply those to your 3D player model just the same as you would your projectile and your slingshot, you know. So that's why they don't get into the models so much, because again, you guys can lose like 12 years fixing a model to be exactly the way you want it. And you would never learn anything except how to get that one model exactly the way you want it. So that's why, but try it. I know, like, if you go through the Unity stuff on just a first-person shooter, you can just drop it in there super easy. And then there's like a default first-person shooter script that already has a lot of stuff in it for moving around the world and everything. So try it.
How to make a person move.
Yeah.
Get hit by all this stuff.
Try it. It's about the same. We'll get there. We get there. You'll have it all. Good.
Yeah.
Everybody back. We have to celebrate here. You guys all here.
Or it's actually, oh yeah, but it's actually like equals new vector.
I will say that my
Look at him come up here. He knows what to do, huh?
And then it's 0.0.
Yeah.
Me? Is me?
Yeah.
It's one group, so.
Do I need to sit back down?
No, you're fine.
Huh?
They're not listening. We'll make it really loud. That thing doesn't work very good super loud, does it? Rick's like, I'm putting my headphones on more. Take your headphones off, you guys. Okay, there it is. That's what I was waiting for. All right, attention please. Attention please. If you didn't get it from the Queen song going, Hey guys, I need your attention. I'm not kidding. It's important. Now, the reason I was playing the Queen song is because we have a champion here. And he took the first place medal at Districts for Skills USA for computer programming. And so we want to give him a hand. Yay. I would try to put it on him, but then I was Yay. Good job. Good job. So he beat some other worthy TC opponents. Yay. But he's going to go represent OTC at state at the beginning of April. So him and I will both be gone on that Friday, the 1st April, or the first Friday in April. So you guys will be here doing great things. But we want, we'll just go to land and have a great time. So good job. All right, and here he's going to learn even more about classes because we do so much with different classes. You guys notice that? How we know that our slingshot class is associated with our slingshot. So much easier for us to visualize those things than in C# and C#2 when everything's kind of console based. Hard to visualize all those classes. We can see it a lot better here. Okay, let's fix it the rest of the way. And then we can get our castle built so that we can crash it down. Now, what code we needed to add here was in our fixed update of our follow cam. I got off on the other script here. Now, in our fixed update, before we get to our LERP, right here after we've gotten our destination variable initialized to our current position, we want to add just a couple of lines to limit the X and Y values to minimum values. So in our destination variable, we want our X component to look at the maximum between our min XY two-dimensional variable that we just set up with a value of 0 and our destination's X position. Which one is the maximum of the two? Then we're going to set our Y destination, again using this math library, mathf, max function, to compare our min XY variable's Y position with our new destination variable's Y position. So we should end up with the bigger of the two. I'm going to save it. Okay, that one. Try it. I had an error there for a second, but it went away. That seems pretty smooth. Seems pretty good. Pretty good, pretty good, pretty good. So we're not jumping. Let's try it again. I want to see that difference. See how smooth it is that our camera just starts moving instead of that kind of lurch that we were getting before. Yeah, I can. So what do you need to?
Static.
Oh, okay. On our projectile?
On the physics material. It was initially set at 0.6, I think, on H.
Yeah.
Oh, on material.
Yeah.
0.6, yeah, thanks guys. The last thing that we have as an issue with adding our follow camera is after the projectile is at a certain height, or if it's gone off the end of the ground, all you see is sky. So it's kind of hard to see how high up our projectile is. So let's fix that last problem. in our follow cam script, as soon as we update our position here, update our camera position, let's update the camera's size. We're using the camera class here, so that's why we have the uppercase C in the word camera, and we don't have main camera. Main camera is our camera. This is the actual camera class that's available to give us methods that control our camera. So now we're saying in our main camera, we want to update our orthographic size to be equal to our destination variable's Y position plus 10. Now, we know from our previous code that we just added in, since we're using that max method, we'll never be able to go negative in a negative position. So we could always add to our Y position for our camera. We wouldn't be overlaying our object with our camera. Okay, so I've got everything saved, a couple little things that they want us to do in Unity. It says to double-click ground in the hierarchy to zoom out and show the entire ground game object in your scene pane. Select your main camera, and in this mode, let's click play and launch a projectile straight up.
Did you see that? What did you do to zoom out and see the entire ground?
Double clicked on our ground. Now we want to shoot that projectile straight up. And it says in the scene pane, you can see the field of view of the camera expand smoothly. So I'm going to stop because I need to check my scene pane. So I'm going to run it because I'm in my game pane, of course, when I'm running. So if I launch my projectile straight up, I can switch to my scene pane and I can see kind of what's happening there. So
The camera like expands.
yeah, you can see its size increasing as it's moving. Looks good. Okay, let's save everything. Save our scene. Save our project.
I remember back in the 8-bit era and stuff, with certain games you could only go, there would be, like if you go past one screen,
Mm-hmm.
it would scroll, like in the Legend of Zelda, it would just scroll to the
No matter what.
Like there wasn't a way you could go, it just transitioned to another scene by slowly moving to the next.
No matter what you did. Okay, the next section is clouds. I hate the clouds. We're not going to do the clouds. I'm skipping clouds. I hate clouds. We're going to come back and do them next time. Because I cannot do the clouds. I don't know why. I'm cloud dyslexic. Everything I do, I end up looking like a bunch of floating white butts or something through the sky. I can't get them right. So we'll come back to those.
Bring water.
Do what?
The clouds bring water, and water brings life.
Oh, you guys are going to make me do the stupid clouds. Okay, so you can laugh at me. Let's do them because they're neat. And some of you who are artists will come up with some beautiful clouds. And then you can laugh upon my clouds. I hate clouds. Our clouds are actually a little bit complicated, so they're very nice practice for us. So I guess we can make that stupid clouds. All right, we need to. Let's make them. we'll do it. Okay, I want to create a new sphere object to start my clouds. So let's do game object, 3D object, sphere. Now for our sphere, they say, hover your mouse over the sphere collider component in the inspector. Right click and choose remove component. Our clouds are not collidable. Yeah, they're just dumb, ugly clouds. Okay, let's set our transform position in our sphere to be 0, 0, 0. And then rename your sphere to cloud sphere. Let's create a new material. There it is, regular material. And let's name our material MAT_cloud. Now, we want to try to use a legacy shader. So let's see what we're capable of doing here, depending on what version we have and what version they had. So do you see over here in the inspector, we want to find our shaders. Do you see shaders? Yeah, I'm on my material.
Underneath the name of the material in the inspector.
Ah, thank you, sir. I wasn't looking up that high. So let's see what options we have. What we're really wanting to do is a legacy shader, self-illuminating, diffuse. So that means that our shader generates its own light. So our clouds will kind of be like glowing in the dark, but not too much because they're diffuse, which means they respond to our directional light. Now let's get a color swatch here.
Which legacy did we get?
We did legacy. Yeah, thank you guys. Okay, and then for our color, they want us to choose something that is like about 50% gray. So, did you get it? Click on that little thing. Now we could type our RGB values if we want to. So we can do that to get exactly what they want. You can change yours a little bit, whatever you want to do, but they suggest 128, 128, 128 with a 255. So it's just kind of a little gray. So it's just got kind of a gray shadowing. So that looks good. I'll use it. Okay, if everything looks good then, let's drag your material onto your cloud sphere. Why won't you work? There it is. It's fighting with me.
I think you have to delete the default.
That's what I'm thinking. It's acting weird. I'll get rid of it.
Yeah, it's not doing it for you for some reason.
Yeah, it's weird. It's got a shader.
What? Sure. And press or delete.
Yeah, yeah. See, I told you I have cloud problems. It hates me. Okay, I'll fight with that later. So let's not worry too much about that because I've obviously got a problem. I'll figure it out. Now, I want to take this cloud sphere from my hierarchy and drag it down into my project to make it a prefab. And I'm going to delete that one then out of my hierarchy. Now let's create an empty game object in our hierarchy. And let's name this one cloud. Now let's select our cloud and set its transform position to be 0, 0, 0. And in the cloud inspector, click add component. And we want to choose script. New script. It's not letting me do that. They say to choose new script. You see it? There it is at the very bottom. And then we can name our script here. So this would be the same as creating it the way we have been, just a different way. So I want this new script to be named cloud. It says to be sure its language is set to C#. I don't see that. But I'll create and add. And it did, so it's fine. Now it says that created a new script and automatically attached it to cloud. So that was fine. So let's make a bunch of clouds. Maybe this will work better than me having to create all the clouds. They've changed it a little bit. Maybe I wasn't the only one that couldn't handle it physically because it's just too much for me. But let's update our cloud script real quick. Now, another thing that's really cool about object-oriented programming, if you're not up all the way to where we were in one of the other scripts, as long as you don't have errors, that's okay, because we can still test our cloud stuff completely separately, because since it's object-oriented, whatever we do for our clouds won't necessarily impact the other stuff until we actually put code in to make it impact. Now, up at the top, let's create some variables. So we're going to use that header and say set in inspector. I want to create a game object for our cloud sphere that we created. We're going to use an integer variable to be how many clouds we want as a minimum, and they start out with 6. And then we want to know how many spheres should be the maximum, and they have 10. Now we need a vector 3. It's going to keep track of our sphere offset scale. And this is a new vector 3, and we're going to initialize it kind of like we did with that 0. We're just going to give it hard-coded X, Y, and Z values.
You spelled sphere wrong.
Oh, okay, thank you. Is that better? Sphere offset scale. Now we want some vector 2 variables. We'll have a few. We need sphere, scale, range, x. We're going to go ahead and create that vector 2 variable as 4, 8 for our xy coordinates. I'll create another vector 2, sphere, scale, range, z. It'll also be a new vector 2 variable. And this one is going to go at position 2, 4. That weird header thing makes everything want to double space. Lastly, we need a float variable. It's going to be named scale y min, and it's going to be set to 2. And we have the f just to make sure it's a float. Now, something for our new programmers here. We're going to create a list. So this list is going to be made up of game objects. So we're going to put that game object data type in between the greater than and less than. And a list is just that. It's like a whole bunch of game objects that we're going to keep together in kind of an array. We're going to name this list spheres. So in our start method, the first thing we want to do is allocate our spheres list in memory. We're going to say, go ahead and set this up as a new list of game objects. We've been talking in C#1 about the constructor, so this is going to run the constructor for our list, and it's going to make up this list of game objects. Because a list is a class. All right, so that should create a list for us to keep all of these stupid clouds in. Stupid clouds. So now I'm going to create an integer called num, and I'm going to use it to create a random number. We're going to use that random class in Unity. That's kind of handier than that C# random class. A lot of stuff in Unity is a little handier than the C# stuff. And we want to generate a random number between the range of our number of spheres. So we had our minimum number of spheres and our maximum number of spheres. And we want a random number somewhere in between there. And we're going to put it in our num variable. Set up a random number of clouds Now that we know how many random clouds we want to generate, we're going to use that to control a for loop. So our for loop is going to generate clouds up to our number. Generate clouds up to num. So for, using an integer named I that we want to start at 0, let's run while I is less than the number of clouds we want to generate, and we'll add to I every time we run our for loop. I feel like this code should be in another method. We should fix this author's code. I'll let you guys decide though. All right, you ready? We got some stuff here for this one. We are doing quite a few things within this for loop. We're going to start out creating a new game object called SP. SP is going to be a game object because we are going to instantiate it as such. And when we run our constructor, we're going to say, use that cloud sphere object. So this is a little different than when we instantiated our apple tree, but it's still what we're doing. We're saying, create a game object named SP. What should that game object be? Well, it should be a cloud sphere, but there isn't one yet. So go ahead and instantiate one. It's a game object. So by instantiating our game object, then we can keep track of it named SP. So that cloud that we just kind of created is going to be named SP. So let's add it to our spheres list. So we set up this list of game objects up here that we called spheres. This new cloud that we just said we wanted to create, we're going to add it to that list. We're going to set up a new transform. And a transform, remember, is just all of those positions, location, rotation, and scale that we keep track of in that transform area on inspector. So a transform object are those things. Now we're going to take that transform object and set its parent be this cloud. So we're going to see why we did that here in just a second, don't worry. Now we're going to randomly assign us a new position to this cloud. It started out based at the position we left in inspector, right? Because we said a cloud is at 0, 0, 0 and whatever. So that's the transform positions it was instantiated with, whatever we set it to. But that's not good because we don't want to have like a cloud emitter. That wouldn't look very realistic, right? Because they would all be coming from the same spot. So we're going to actually change its position a little bit randomly. So let's create a variable called offset. Now, what in the world is that? Good job. He's looked it up. That's perfect. It sounds like you did. Our wealth of knowledge back there. Do I? Good. Now let's update our offset, our X position. So we'll use that random offset value to change the position of each of our positions.
Oh, so basically, the random inside unit sphere is kind of saying it's a point, it's a specific point where it generates.
An XYZ point. Very good, very good. Okay, so we're going to update our transform then that we've created and set its property local position equal to that offset that we have been working on. Now, randomly assign a scale because we want some of these clouds to be big and puffy and some of them to be smaller. So we'll update that scale value also. We'll set up a variable to hold it. Our normal scale, of course, is 1. Sphere scale. Range x dot x. I've got an uppercase S up here. There's this. There we go. And so we want to update that scale. Again, we're going to generate a random number based on our scale range variables. And if you remember, we set those up at the top. Now I'm going to go ahead and zoom out just a little bit so I can see that a little bit better. And I basically want to do the same thing. That should stay X. So we want to do our scale range Y. And then finally, for Z,
We don't have a scale range Y.
you should. Are we missing it?
It's a vector 3.
Should have one. Hang on just a second. We'll go up there and get it. It should just like, if you scroll up, it should look just like the others. Yeah. Let's make a Y. We need a Y. It's missing. What should our Y be? It should be 3 and 4. You can try it. I must have skipped it. I was getting done. All right, fix that problem. Once we've got all of our scale properties set, it was 3, 4. We're going to adjust our Y scale by X distance from core. Yep. Helping me there. So we want the absolute value. Let me finish here, or I'll not say anything right. Sphere offset scale dot X.
adjusting the scale value of y based on x and x based on y.
X based on Y.
Yes, because you're adjusting the value for scale of the y dimension
Mm-hmm.
by the x value.
Right. And we're taking the X value, if you notice when they say from the core, we've got the absolute value, so we're not going to take a negative. And then let's update our scale. Y value,
Then we get
whichever is the maximum. What do you got? Finally, let's update that transform that we created to use this new scale that we've been calculating. Now in our update, we've got an interesting thing. We're just going to check to see if somebody has pressed the space bar. And if so, restart. That would be nice for us getting stuck out there, huh? Let's create a restart. You what?
I had a question actually. I actually was looking this up recently.
Uh-huh.
There is two different types of get functions. I know there is one's for keyboard input is get key.
Uh-huh.
And yeah, I guess one thing I'm definitely trying to figure out, I don't know if anyone else knows this, but the get button
Mm-hmm.
function, how, I guess the thing I've been trying to figure out is how would you later on, I'm not necessarily saying if you know, but
Uh-huh.
that's one thing I've been trying to figure out is learning how to do button inputs,
Mm-hmm.
meaning game controller.
Uh-huh. So have you had any luck? I know you've been.
I mean, the closest thing I've been hearing that I've been watching and looking through Stack Overflow and stuff, the closest I can think of is that they say there's called get joystick or joystick num.
Mm-hmm.
Joystick num. Or I think you might go to the input manager is what they were saying.
Mm-hmm.
It's something like that. And you select which button matches the name of the input.
Well, I think what you might be talking about is like, there is a manager on the Unity.
Yeah.
When it's got like file 1, file 2,
Yeah.
mouse 0, mouse 1. Those are all preset. You can change them to
Yeah.
whatever keys you want.
Yeah.
And but those are kind of like the get key down by getting
Those
the
are
get
only.
button and then half the name. Because like those are like pre-done. You can
Yeah.
change what they're attached to.
Yeah.
So you're just mapping those different inputs to your different
Yeah,
joysticks if you want to, different buttons. Mm-hmm. Mm-hmm.
So they already had those set up.
But you should be able to map whatever you want to.
What I'm trying to do is instead of keyboard and
Mhm.
mouse input, I'm trying to learn how to do controller input.
Mm-hmm.
Oh,
Because that, like, it's.
yeah, there's tutorials on the controller, correct?
Yeah.
And actually, there's again, they got one that's universal for all platforms. So they do the WASD or up key or whatever the controller will work. I'll have to look for it again. I see it the other day.
Well, that's what I was thinking, that you just like use keyboard input, but then you map your controller to it so that it acts like it's doing the mouse button and stuff. Okay, let's know. So what's this statement saying here, this for each statement?
If you're just looking in the list.
So our list spheres, we have all our clouds in it, right? So each cloud in the sphere list is going to be processed individually by this for each loop. Each one is going to be assigned a variable named SP, and then this code will execute this body, which will destroy that game object. So in this loop, we're looping through our spheres list and destroying all of those game objects, and then we're going to start over.
So
That
it's
makes
going
sense?
through the list SP of spheres.
No, our list is spheres,
Sorry, that's
and
right.
each sphere will be named SP
Yeah.
within the for each loop. So we could do other things to it if we wanted to there, but that's what it would be named.
Yeah.
Okay, so we should do our cloud here. Let's save our cloud script. And let's associate it with our cloud object in the hierarchy here or in the inspector. Oh, we already had it associated. We didn't have to do anything. Okay, click play. Do what? Set our prefab. Okay, so our cloud sphere should be set to our cloud sphere.
Mine says cloud already exists. Cloud already completes definition for sphere scale range.
We'll look at it. Now, that was not too bad. I like the way they changed it. We don't have to draw the cloud, so my inability to do art didn't hit me. Now, when I press my space bar, it's destroying my clouds, but I'm not seeing where the new one was generated because I spit my projectile out. Yes, sir? Nothing. Look at this giant cloud that I have. Mine is coming out very weird. Let's fix them up and see where your cloud is. Okay. Just so you can see that it's randomly generating it. Start, yeah. And now that it's all started.
Let me, I'll get to the, I'll go ahead and just go to use the.
Oh, come mine. So, in this project, go to edit, go to project settings, go to template. And these are called, and over here in the inspector, that what's called axes. And these are the different ones that are all preset and you can change. You can see them down here. This has joystick button 1, joystick button 2. You can change all that stuff. And what you would do is, you know how one person moves. Were you here for the game demonstrations? Because to get access, remember that one? That's how you get access. You get access, and then you can literally do by file 1, file 3, you know, and you can get my button and provide one to each one. And see, that's the type of that's one of the
I guess what was confusing was I watched a tutorial that was like 79 videos. And when I was going through them, there was one guy saying he knew the preset values. He's trying to get joystick out.
Yeah.
And their one for PS4 was 19, Xbox was 33.
Okay.
But I didn't know what to do for like PS3 controller.
Yeah, I'm not sure. I know. I don't know. I think they yeah, universal platform. Like you're looking for.
Cloud sphere not existing.
reason I was asking is like, I know what to technically do. I just don't know if I need to, what name I'm thinking for this one.
Okay.
Like the buttons or the joysticks. Because I think you have to give it a specific name.
Yeah, I do. Yeah.
I at least was wanting to try that. But that's kind of why I actually, if I had a little more time on the previous project, I would have done it that way.
Yeah.
But I did, since it was in a, since.
Okay,
it
we
was
got
kind
some
of
to
in a
fix.
hurry, board, I decided
Let's
to
help
stick
him here. Okay, we're ready. All right. Show everybody what's going on.
When I try to run it, it says.
Who do we have?
Not exist in the current context.
Oh, sorry, Isaac, he's right there. All right, so what's going on with it then?
There's line 27, like this, right?
You see it? What?
A public game object variable is spelled differently.
Oh, good job. Extra L.
Oh.
Save that. And again, you guys, that's something that we would have found if the Unity and Visual Studio interfaces were installed all the way. So if you have your laptop or something where you can control that, that would have been a little easier to find.
Now it says next your offset scale is not existing on the print line. Okay. Wait, there was line 30.
We have spheres.
Up where they're declared in your header area. Get rid of the, make them not be plural. Edward, up at the top.
Yeah, I know.
Okay.
Oh, wait.
Nope, they're still wrong.
Wait.
Oh, you got it. Never mind. I'm seeing a delay.
Your scale range Y.
Yeah, you don't have a scale range Y. You need to add another variable.
I did. What's sphere's scale range Y be for the cortex?
3, 4. Is that what it is?
Yeah.
Oh, okay.
Is it happy now?
Now it says type for is not in definition for Z. And no extension method Z of type Unity is
So go find that line of code.
40. Okay. Wow. What about what do I? Also,
X and Y. They should still be X and Y. So every time they should be X, then Y.
can you please get your arrows out of the way? Thank you.
So the first one should always be X. So, yeah, there you go. And the second one should always be Y in all 3 of those lines.
Oh, okay.
Wait.
One more.
This one still always got X and Y. Edward, you see me? See, this should be a Y. X and Y in each of them. Very good. Okay, close out. We'll get those fixed in a while. I can help you with those. Let's look at Isaac's because I can't help him. I don't know what's wrong with it.
All right. For whatever reason, the clouds don't appear.
No clouds, no clouds.
Okay, they got away. Okay.
Did you put the cloud script into the file?
Yes.
Did you put the prefab into the cloud script?
Yes.
It's just not anywhere. So I'm thinking it's the material. The material is invisible or something.
Yeah, did you delete the mesh? So wouldn't it hit run and watch your hierarchy and see if it's generating the objects?
Yeah, we should be able to see it. Run it again for us, Isaac. So here in your hierarchy, no. Is it running? Can't tell. Yeah, it's running. So it didn't generate it for in his hierarchy either. It's just not doing it.
Well, I'd go look at
Isaac.
the
On there.
script and see find the line where you
Nope, on the
instantiate-
far end over there, Anthony. You're so good.
find where you instantiate the cloud in your script.
Clouds just don't fire.
What do you see?
Oh, yeah. Yeah, he's got his alligator the wrong way, so it's never true.
Oh, you guys are so good. Uh-huh. No problem.
My brother has an interesting story. My brother has a big concert today in Pittsburgh.
Oh, fun.
So
Well, have a good time. We'll see you next week.
You guys want to tackle mine next?
Yes. Oh, look at that. Good job. Okay. Let's look at Jay's.
I didn't get it.
Well, good job, you guys. That was a good looking cloud, actually. Okay, let's look at Jay's. See what's wrong with it.
Now, where do I go for this share screen?
Are you connected to the Zoom?
It doesn't restart properly still. I'm watching a hierarchy restart. The ball's still there and the camera still stays. At least on mine.
So
But I can watch the hierarchy.
I think it's rerunning the start of these clouds. Is that what it's doing?
Yeah.
We should put a print statement in there to be sure.
Click on your cloud coming out.
Awesome. So what happens is when I go to make my balls, it crashes, and then it complains about my on mouse down line 73, and I don't see anything wrong with it.
No.
Says everything on Riley.
The only other place that we send the mouse event is right here.
That's correct.
Okay, thank you.
You have mouse button 0 is the left one. Okay, still correct.
Cool, thank you.
Fine, model first. And you got everything on Unity set correctly, like everything scripts the right places?
Well, yeah, I mean, just random.
It was working before?
Well, it stopped working as soon as we started messing with the ball physics. So,
Click on the ball? Mine? Maybe something I messed up on that. Okay, get your body on the ball.
Balls,
You got the material on it.
A lot of
What's the physics material look like? That's what the man said. Correct. Yeah, always done when we got like physics on the ball.
I think so.
Oh, you want to see it? I have it.
You got a sphere collider and your body on there. You got a mesh controller.
Do you want to? I like this. That's a kiwi bite. I've never seen a kiwi bite. The KIV is. It's so good.
What's that?
So, yeah, that's where the stuff is.
That could be what it is. It could be, I don't know if there's something on it that option that's checked. I don't like.
Right, redirect to like God.
That might not be an issue.
Yeah. There it is. And then it's that CIS220 SV.
Okay, we have to forget Martin.
And what did you change your schematic for? Okay.
Oh, that's true. Yeah.
Okay, Martin, share yours. These guys are working on this hard problem. Okay, Martin's not seeing the halo. When he runs. I know it's right there, but when he runs, it disappears. Show him what it doesn't do.
So something on
Your mouse?
on mouse enter.
So let's look at that console screen.
Print on mouse enter. Yeah. So it's on mouse enter. You're getting printed.
I don't know, where's your console screen so we can see if we're getting that message?
Probably to open it.
Try running it again, and then just wait on your console screen.
It's in the window. Go to window. Then go to general.
But that's the documentation.
All right.
Okay, leave that open while you're running.
Now run it.
No.
So your on-mouse enter is not getting called.
And there's not even.
Can you go back to your slingshot script?
Well, here, I can just pull it up. What is it? Just do,
There is a line.
No, I see it.
Yeah, but it's not good. It needs to update it.
Yeah.
Doesn't that should be
No. That's a built-in function.
Mm-hmm.
So like, so it knows automatically, like the start function, it's all built in, so it's all.
Yeah, it shouldn't be a problem.
On mouse.
Quick question. So, on keybind down or
So
something,
you can get
it
rid
was
of that
something
else.
similar to that. I don't
That's
remember
blank
exactly.
else.
I think we should get rid of that too. That worries me. I don't think it's causing any trouble, but I just think it could. Sorry, do it.
Yeah, I mean,
So